Hello everyone. So as I sent a notification, we are doing a synchronous lecture for the lab class this week, Wednesday. So I will cover the demonstration part of the SPSS program regarding ANOVA, and also I will cover a little bit more about the research method. So this course is kind of the combination of the two courses. So one part is the lecture we do the Tuesday and the Thursday about the mathematics and also the conceptualizations of the statistical method. And on Wednesday, we usually do the lab class for applications in the research method. So using SPSS program and how to apply the statistical method we learned on Tuesday and Thursday. So today I will cover more about that. So more about basics of the research method and what are the basic requirements of the data analysis and also the quantitative method. But before that, anyway, I will cover what are the basics or what are the applications of the ANOVA using SPSS program. So before that, let me move my screen here. So if we have extra monitor, so especially when we are doing the virtual format, or when you just watch my program in terms of the SPSS program demonstration or any kind of the asynchronous lecture, if you have the dual monitors at your home or if you bring your laptop as extra monitor, it will be usually better. So for example, so maybe my office is a little bit messy. Sorry about that. So as you could see, I have this screen. So about my schedule of the testing, and also this is my main screen I use as my lecture. And as you can see, oh my gosh, so it's the SPSS program update for the version 27 is not working as well. Anyway, so if we have the two monitors like that, so maybe we can use one monitor as the demonstration or the video, and another monitor, maybe the public computer using SPSS program as your work computer. So you can use the dual monitor as the one monitor for watching the video and another monitor, maybe a public computer as your work computer because you are using SPSS program. So that will be always more helpful. Okay, so categorical independent variable and metric dependent variable. So far, before the midterm exam, we just use the dependent variable as dependent variable as metric variable because we had to compare mean of the two groups. So independent sample t-test, we were using two groups as male and female or over BA or below the BA. So we could just use the binary variable as independent variable. But in ANOVA or in other methods we are using later, we are just using some groups of the variables as having 3 groups or 4 groups or 5 groups together. And then we are using the dependent variable as a metric variable again because we are still comparing the mean of the groups. So condition is when we have a categorical variable more than 3 groups. So maybe 3 groups. And metric variable as our dependent variable. So that's the condition. We are using ANOVA, which is analysis of the variance. So I will show you what are the requirements, details of the requirements. So with several categories or several groups in your independent variable, which is the cause of the relationship. So categorical variable including more than 3 categories. So when you have 2 groups or 2 categories in your independent variable, you can just keep using t-test or independent sample t-test or something. But more than 3 groups, including and more than 3 groups, you need to consider ANOVA as your method. Also, it depends on dependent variable again, because when your dependent variable is a metric variable, it means that you can calculate mean of your dependent variable based on the groups in your independent variable. So based on combination of your independent and dependent variable, you are choosing the statistical method based on those conditions. Again, if your categorical independent variable has more than or including three groups, you can use ANOVA. But also, dependent variable must be metric variable. And also, as I covered on, so let me correct that. As I covered in the lecture, the Tuesday lecture, if there are three or more groups, so we are just checking whether so all the groups have the same mean. So there is no differences in mean of the groups. So there is null hypothesis. As I said, it is very cynical. But alternative hypothesis is very important. At least, at least one group, at least one group has different mean. That is alternative hypothesis. So one tricky part is that the alternative hypothesis is at least one group has different mean because I said all the groups have same mean of the dependent variable. So in order to break the logic, of the all groups are same, if one group has different mean than others, so it can break the null hypothesis. The assumption of the null hypothesis is that all groups are different. So all groups are different. That's the null hypothesis. But there's one tipping point as if the one group has different mean, then we can break the assumption that all groups have different mean. So at least one group has different mean, you can break the assumption of the null hypothesis. So that was why at least one group has different mean was the alternative hypothesis. So racial differentiation of the income. So racial differentials or racial differentiation of the income. It means that based on the race, so the null hypothesis says all the races would have the same income level, so same mean income. It means that they argue. So the null hypothesis, these are very cynical people arguing that there is no difference of the mean. All the races have the same income, so there is no inequality. But alternative hypothesis says at least one race has different average income. Then that will be alternative hypothesis. So we covered that in the calculation part, but we are in the SPSS program part, so I will skip this part because SPSS program will help you finding those statistics. Okay, so usually when I do the asynchronous and the video lecture, I usually divide the window as like this. So this part is the instruction, and this part, the right-hand part of the screen, is the actual SPSS program. So we can go. So sorry about that because I'm still using the SPSS 25 as I showed in the previous window. Yeah, so I got the SPSS 27 from the Department of the Technology, but for some reason, I continuously cancel, so it continuously cancels the downloads, so I could not update the file, but I can do it at home again, so sorry about that. But still, I'm using the SPSS 25, so if there are some discrepancies of the version, I'm so sorry about that. I will fix it as soon as possible. But anyway, so we are going to the comparing means again. So analyze, compare means, and so we use the one sample t-test, independent sample and t-test, and the paired sample, paired sample t-test. So we use the those two menus, so one sample t-test comparing sample mean and the population mean using the sample standard deviation. And the mean of the two groups again. So we just calculated the paired sample t-test, but we're going the one-way ANOVA. So clicking ANOVA. So if we didn't change the option of the displaying the names as alphabetical order of the labels, you may use this screen, but we just need to make the names as the list of the variables. So in this example, so I use the dependent variable as income. So because we set up the null hypothesis as a racial differentiation, research question as a racial differentiation of the income. So the very good example is the CONRINC, which is variable information. The R's income, I mean the participant or respondent income in constant dollars. So this variable is measured as $1 interval. So $1 interval everywhere, all the intervals are measured as $1. So this is the very good example of metric variable. So this is very good variable as dependent variable to calculate the mean of the income. And the race is the factor because race has white and black and others. So it has three categories. So factor is a variable as the factor. Factor is independent variable because it is categorical and has including or more than three groups. And also we are choosing the option again. So option here, descriptive statistics to show, and also the means plot. And continue. Okay, and click OK. So it shows some result here. So maybe I'm not sure. I'm not able to enlarge the screen now, but let me show you the screen in the better resolution. Okay. So this is the graph I created for the better depiction. And so when I created the bar graph, so showing the racial differentiation of the income, so we can see that the white race would have the highest level of the mean income, so a little bit more than 40,000. And there are some racial gaps. Anyway, they are not same at all in the sample data. But after creating, so this is the output here we can see. So I'm just showing again. Okay, so we can compare that the mean of the sample. So mean of the racial groups are different from each other because they are not same. But we are not sure this is caused by chance or this is caused by the real differences, at least one group from other groups. But again, in the lecture, we covered that how to calculate based on the level of measurement, based on degrees of freedom, the within and the between and the within. So we could use the degrees of freedom as n minus j and j minus 1. We covered it before. But in this time, we can use this important part as significance. So again, it was very important criteria, right? So if the significance value or the p-value, what we call the p-value, if the p-value is smaller than 0.05, so UDC, so in the higher version, the significance value would show that it will be smaller than 0.001, like that. But anyway, it indicates that the significance value or the p-value is smaller than 0.05. Anyway, 0.0001 or 0.000 would be below 0.05. So in our hypothesis testing and the conclusion, we can reject the null hypothesis. So we can reject the null hypothesis and we can say that at least one race group would have different mean from the other groups. So that will be the basic conclusion part. So step number one, setting the null and alternative hypothesis, and step number two, finding the degrees of freedom and finding the F critical, whether if there is some F critical. If we find the F statistic, so we have the 15.611 here. If the F statistic is over some number, then we can reject the null hypothesis. But if the F statistic is below some number, we fail to reject the null. So we would say all races have the same average income. So that will be the criteria we can use. So again, so by using these menus again, so one-way ANOVA and dependent variable as metric variable, and the factor variable is your independent variable having three or more categories. Then by checking the descriptive and the means plot, we can find some level of differences of the categories we have in our independent variable. So this is one step, so one formal steps of the hypothesis testing, and one more formal steps of the statistical method of the ANOVA using categorical variable and metric dependent variable. So again, as we had in our on the midterm exam, the respondent income in constant dollars would be dependent variable, and the rates would be independent variable. So you can find the information in this table. All right. So degree and income. So this is very conventional example as well. So after creating the bar graph here, so the x-axis is the categories of the degree level. So higher degree means the higher income. So graduate degree, they are usually more likely to earn more than $60,000, and if the people have the bachelor's degree, a little bit lower, but still more than other associate degree, a high school diploma, or less than high school diploma, less than high school diploma. So we can see the increasing pattern of the income in here, but we are not sure these are happening. So this is happening by chance of the data problem or error, or whether we have some real association between degree level, I mean education level, or income. So I know many of you are working on this topic as your potential final paper. So I will show you how to do it. All right, so again, let's use. So analyze again, compare means, and one-way ANOVA. Okay, so as we are using the same dependent variable because we are comparing average income by degree level. So we can just remove the race variable, but find the degree variable. So the variable is R's highest degree and divided it. So we have 5 groups. So less than high school, junior college, bachelor's degree, and graduate degree. So we have 5 groups here. So we can use the factor and the options. We already have descriptive and means plot. We can click OK. All right, I'm not sure why it shows the means plot again instead of the thing, but anyway. All right, so let me enlarge because this is too small. So let me show you the bigger table because they are identical. So the mean, we can see the graduate degree has the highest level of the income, mean income, and we can find that the significance value is below 0.05 again, 0.05 again. So, okay, so in all the formal steps, we can use the number again, but the F statistic is 63, and then the significance value is below 0.05. So we can reject the null, and then we can say that at least one degree level, or at least one degree group has different average income compared with other groups. So it's very good. It's very good method anyway because you have the better and you have the wider range of variables because in the t-test you should have used only the variable has 2 groups, right? But in any kind of categorical variables having 3 or more groups, you can use the variable as your independent variable. So it will be the better way to analyze the group differentiation of the income or the group differentiations of the education, like any kind of metric variable. So let me show you one bad example. So I repeatedly said your dependent variable must be metric variable because we are comparing the mean of the groups. But in case when we cannot find, so when in case if we cannot find some mean of the groups, for example, if your dependent variable is categorical variable, that is very wrong, very, very wrong information and very wrong method. So the income, so income variable is, let me show you in the program. So frequency table and the income. All right, and maybe income 16 as well because they are very similar. Okay, income or income 16 or income something. Okay, so these are very bad examples. So less than 1,000 and 1,000 to 29,000. So it looks like, so some of you might think these are, so this is the example of metric variable. However, let me show you in the bigger screen. However, these are not metric variable. So this variable is ordinal variable. Okay, so I would like to ask the question if you were in the in-person classroom. But so let me go back. So let's go back to the basics of the level of measurement. So let's say um there are several conditions of the metric variable says you must have a fixed interval. So all the intervals should be same in everywhere. So as like the incoming constant dollars. So the interval between $0 and $1, there was one. So the unit was one. And the interval between 2,999 and 3,000. So there was the interval as the $1. So the $1 in this part and $1 between 0 and 1, that was identical. So the distance was identical. The distances were identical. But in this variable, so maybe the less than high school is coded as 1 or 0. The next category, so compared with the previous category as less than 1,000, maybe it means, so anyway, $1,000, so 0 through 1,000. But here, 1,000 through 29,000. So it's about. So if we subtract the 1,000 out of 2,900 or about 3,000, this is 2,000. So from here, already the interval is not identical. The ranges are not identical, right? So the first category says some range of the 1,000. The second category, all right, oh, maybe 2,000, amount of 2,000. And three, maybe 1,000 interval, again and again, increase order. And the last category, wow, there are $5,000 as interval. So again, so let me make it larger. I know you can see it later. So based on the location and based on the category, there are very different level of the distances of the intervals. So in this one, so if you use this variable as dependent variable, the result says the white category, the white race, the total family income is the mean of the total family income is 11 point something. But what does that mean? 11.15. Does it mean maybe $11,000 as their total family income? Not sounds right. Uh-huh. $10,000? Not sure. Because the unit of analysis is not very clear. Because in here, these are just categories, not the absolute value or the unit of the dollars or something. So if you use categorical variable as your dependent variable, in this time, if you use ordinal variable as your dependent variable, that is a wrong condition. So please make sure, so whatever in your SPSS test or lab assignments or your final paper or final exam, please make your best sure and make your best knowledge to find the dependent variable as metric variable. So that will be very important condition in ANOVA. So again, in the concluding remark of the one example, I have more examples. You can. So ANOVA, you can use some group variables as your categorical variables or category variable as independent variable. But your dependent variable must be your metric variable. So that is very strong condition. And also, as you remind, so let me remind you about the alternative hypothesis. So alternative hypothesis was saying at least one group is different from the other groups. But it's not very useful sometimes because sometimes you want to know. So it's very limited information because it kind of trick that when one group is different from the others, at least one group. So at least one group means one group, at least. If one group, so if one group is different from the others, but all other groups are the same, so it's still we can reject them all, but it does not mean that there are super big differentials by the group. I mean your independent variable. So in order to compare, so in order to find which group or whether all groups are different from each other or which group is different from some other groups. So if we want to go more details of the analysis to see what are the details of the differentiation, we use post-hook comparison, which is the additional method in the statistics program. So it's too tricky to use the hand calculation, so I will not cover this in calculation part. So I will just cover it in SPSS part. So coming back, again, so coming back to our example of the analyze, compare means and the independent sample. So let's go back to the race variable again, because that is the easiest one. So in option, we use the descriptive and that means plus, so we don't need to change it. But we can go to the post hook. So here, as in the lecture screen, post hook and the post hook. So mostly we use, so it depends on the textbook, but we usually have the two key, not turkey or turkey or two key, but it's two key. So I searched the pronunciation, but it seems it's not from the English. But so there's Tuki and Schefe. So it sounds like a German or something. But we usually use the Tuki and the Schefe. So I don't differentiate. So I don't consider whether one is better than the another. But you can just choose either one. So I don't think there is ultimate answer about that because some situations Tuki is better, but some situations Shepe is better. So I can find which one is better. So anyway, you can choose Tuki or Shepe, but let me show you examples of the two options. So you don't need to check out our others. So just continue and okay. So there are some combinations of the table. So let me show you in the bigger screen. Okay. Okay. All right. So the star means the significance level is below 0.05. So it says a little bit of complex one, but the star means there is statistically significant difference between two groups. Sorry, pronunciation. So if there is a star mark in that category, in the pair, so in the first part, the white and the black. So the mean difference between I and J and the star, it means that the white and black groups have statistically significant difference in income. So the star means they are statistically significantly different from the other group. So the star means white group and the black group, I mean the white race and the black race have statistically significantly different income compared with each other. So, but in here again, the white and other, it has star again. So white and other group, they are statistically significantly different from each other in terms of income, right? So in black and white, they are just the reputation and other race and the black race. So we can see that, so maybe move this one. So we can see that there is no star. So there is no star, and it means that there is not statistically significant difference in terms of the income. So black and other, they are not statistically significantly different. But again, the other race and the white race, they are statistically significantly different from each other. So when you find some pair of the groups with the star here, it means that they are statistically significantly different from each other. So that is the information we can find. So let's use other examples using more complex variables. So HH race, which is the household race, this variable has more affluent information of the race. So the first category is the white, second category is the African American, third category is American Indian, and fourth category is Asiatic and Oriental. So as I always, as you might notice, so I usually not try to indicate the category based on the skin color or something. So usually I try my best to say the African American instead of black because it's sometimes it is attached with the racial values. But Oriental, so it's a little bit. So in terms of sociology, coming back to the race and the sociology, Oriental is fine to attach to the materials. It's like the food and Oriental food, that's very fine. But if somebody say the Oriental people to me, I feel a little bit strange and usually it's kind of inserting words to the racial group because Oriental, very old word. So for me, a long time ago, yeah, some old people told me that you Oriental people, but that's not very not very good experience. But anyway, coming back to the lecture. So the fourth category is the Asian, and the fifth category is the others and mixed one. So the DK and NA, these are the missing values, so maybe we can ignore them. But anyway, there are five groups in total. So we can have five groups as the racial groups and the race groups. So let's use this variable as independent variable. Okay. So HRH. Okay, so as we already have the post-hook, so we can just keep okay. Alright, there are so many mixture and the combinations, but let me show you. So in result, there the significance value is below 0.05. So we would say they are statistically significant. So at least, so again, let me write it here for your record. So at least one race group has different average family income in constant dollars. So that will be our alternative hypothesis. And as we reject the null. So that will be our conclusion. Anyway, so after finding the Shepe or Tukey, so in the time we were doing Tukey, so stars here. So compared with the white African American would have the statistically significantly different mean income. I mean, the different mean total family income. So because it has a star. So in terms of the total family income, mean of the family income, white race is statistically significantly different from African American, but not the case with the American Indian or Asian people. But white versus other race or mixed race, they are statistically significantly different from each other. So that's the conclusion. And African American as the reference group, white and Asian and other races, they are statistically significantly different from each other. So in terms of the mean family income, we can find the racial differences based on the result of the post-hook ANOVA test. So based on the Shepe, compared with the white group as a reference category of the race, African American would have the different mean income in terms of the total family income. And then the stars are not indicated, and compared with the white, other race would have different, statistically significantly different income in terms of the total family income. So that will be the criteria we can find. Alright, so again, one another example would be the household type. So if you try this variable in the SPSS program, because we have so many categories here. So this is the descriptive statistics we can find, and in this result, the significance value is below 0.000 something. So anyway, it's smaller than 0.05. So our conclusion. So step number 4 in ANOVA is reject the null. So the rejecting the null that all the household type would have the same mean family income. But we just say that at least one type of household would have the different mean family income in constant dollars. So that will be the conclusion we can see. All right, so what are the possible categories we can find? Sorry about this. Maybe I touched the wrong button. All right, so let's find some pairs. All right, so okay. So using the reference category as the married couple without children, a single parent household would have the statistically significantly different family income in constant dollars. So the dependent variable is the family income in constant dollars. So the two groups, so married couple without children and the single parent household, they have statistically significantly different income. I mean the mean family income. All right? And what are the other pair of groups? So the other pairs are maybe other family without children and and single adult and also oh no, some other groups that could be couple without children and no family, no children, and also the unsure about their household type, no children, and other family with the children, and what are others? Oh no, sorry about that. Oh my bad hand skill. Cohabiting couple with children. So these are some pairs of the groups would have statistically significantly different income in the mean income in terms of the family income in constant dollars. So by using the star marks, we can find what are the pairs. What are the pairs of the groups that we can find as a different income level? So that will be the key as opposed to. So with the very simple, very the default option of the ANOVA, we could just find maybe at least one group would be different from the other in terms of their income in the dependent variable. But in post-food test, we can find some pairs. So compared with your key category, maybe a key category in your independent variable, you can find some pairs of the groups in groups or categories would have statistically significantly different outcome in mean outcome of your dependent variable. So that will be very important result you can find. So you can find again, and in your lab assignment and the SPSS test, you will be able to test or practice your knowledge using the different variables. Okay, so choosing your variables will be very important first step. Your independent variable, it should be the factors, could be put in the factor in the SPSS program. It must be categorical variable having 3 or more categories. But more importantly, your dependent variable must be metric variable to use the mean of your dependent variable. Okay? So simply, you should be able to use mean, average of your dependent variable. So your dependent variable must be metric variable. Okay? So that's the concluding mark, and see you in the next video.